SMASH, has been Topics in Current Science Research. Today we actually had our presentation, and my presentation, we worked with a scholar here at Berkeley, and his name's Sean McDougall. We worked over in the mathematics department. I find this class, Topics in Current Science Research, interesting because it gives me an opportunity to get the chance to see different kinds of maths and sciences that I might like in college or in high school. So I might get the chance to do that. Our project was about ultimately finding the shape of the universe. One thing that I learned how to work together in groups, and I learned about our topic. What I did learn about working together in groups, I had 3 other people to work in the groups, Megan, Janae, and actually Kenman. It was difficult working together because we had to come up with our own paper. It was a 2-page paper, and we had to work together to do it. And we had to make a presentation in front of our entire class, which was also difficult. It was hard these past 2 weeks to do that because it's hard to take time out every day and sit down with your entire group and make that presentation and make that paper. What we actually did, it was harder for us to make that paper, so we tried to divide everyone up and have their own little section and then come together and try and bring everything together. We actually finished our presentation and our paper today, which is probably not the best idea. Through this experience, I have learned a lot about working together in a group, especially on presentations, formal like this one. Our project was about finding the shape of the universe. We learned through this you have to use classification of dimensions and find those shapes in dimensions so that you can ultimately find the possibilities of shapes that our universe can be. So there was 2 ways that we classified dimensions. One was by classifying shapes and figures. The way that we did this was, first we started off by classifying the 0th dimension, which is obviously a point. There's nothing really that you can measure about a point. That's why it's the 0th dimension. The first dimension was what we classified next. It was harder than the rest. It was easier than higher dimensions, but this first one, it was harder to find a rule that we could use. We started off by trying to see if a line was one-dimensional. We used the rule that if you take a single point, which is what lines are made up of, they're made up of points, and you take it off the line, you get 2 points. So our rule is that if an object can be divided into 2 by a 0-dimensional object, then you can get a 1-dimensional object. This rule works for other things, for higher dimensions. So say you have a square, which is filled in to be two-dimensional square. You can't take 2 points away from it and expect it to divide it into 2. You'd just be taking away those 2 points. You have to take a 1-dimensional object and divide the entire thing. So our rule was that if you take the previous dimension from the dimension you're trying to classify, then you'll be able to see what dimension it's placed in. So this is a part of the first dimension because you can use a 0-dimensional object to take it away. This is part of the second dimension because you can use a 1-dimensional object to split it in half. Another way that we classified different shapes into dimensions was by using the Euler characteristic. The Euler characteristic has a formula that we actually kind of discovered. It's this funky looking X. It stands for chi, which is the Euler characteristic, equals F, which is the number of figures, plus P, which is the number of points, minus E, which is the number of edges. You can find the Euler characteristic of, say, a square by triangulation, and basically that is just turning the shape into a bunch of different triangles. This was an easy way that we figured out how to do it. So if you count everything up, you get 5 points, 4 number of figures, there's 4 triangles, and there's, 8 edges. So ultimately, your answer would be 1. So chi, which is the Euler characteristic is 1. Any object topologically equivalent, which means like a circle is topologically equal to a square, and so is all other polygons, because you can mold it without ripping or breaking anything. So anything topologically equivalent to a square, it has the Euler characteristic of 1. And so that way we can classify different objects into different dimensions. So what I learned through doing this project is that teamwork is necessary if you want to get things done. I also learned a lot about math and things that I was interested in. So ultimately, I think that my favorite course so far, at least, has been topics in current science research, which is a mouthful. But yeah, so thank you.